Hi, I'm Kevin Hauser. This is video 8 in our in my video series of 10 that is in support of my new book. This particular video is going to be on AirOS, so we're going to look at some of the unusual granular settings in AirOS and have a better understanding of when we would use them or when we would apply them. Stay tuned, here we go. Okay, so here we are in the AirOS radio, our outdoor radio that I have sitting here on my desk. This particular outdoor radio is currently not set up to be an access point or a station. Everything is sort of just not configured at this point in time. But I do want to show some settings on here that people may get confused by. So let's get down here to the bottom of this screen so we can see what I'm talking about. So under the advanced, which by the way isn't open by default, we open up the advanced and you can see on the left we see AMPDU question mark, we see AMSDU question mark, and we see AirMax priority, maximum data rate module, and then on the right we see calculate Eirp limit. We're actually going to start right here at the top where it says AMPDU. So this stands for AirMax protocol data units, and this is basically a way for you to kind of tweak how many frames are going to be acknowledged at one time when you actually have a radio connection turned, a radio connection actually set up. So in other words, if you have a great signal, if you have a super clean network, you can crank this all the way up to 64. And basically all this is going to allow you to do is recognize or acknowledge more frames at one time. That's the whole idea behind this. Now the bottom underneath there we have AMSDU. This is merely an on or off checkbox, and they recommend that you can turn this on in a clean environment, but in noisy environments you may want to turn this off. So those are those two little settings. Again, this would have to do, if you're going to use these, you would have to have a clean environment to actually make these work. Underneath that we have AirMax station priority. Okay, because at the top, since I haven't selected access point, this by default will become the station. So you can only set AirMax station priority on a station. And if we pull this down, there's 4 choices here: high, medium, bass, and low. And by default, it's set to bass. Well, what does all that mean? Well, what that means is that outdoor radios use a protocol called TDMA to actually talk to clients and to make connections and to share available airtime on that outdoor radio. So one of the issues you may have in an outdoor environment would be some clients may be having a better signal than other clients, or some stations might have a better signal than other stations. So I've created a horrible little paint drawing. Let me open that up for you to show you what I mean. And down at the bottom we have our ugly little noise floor here, a little red noise floor. And here we have a make-believe tower with a sector antenna on the left here. And we have some devices connected to that. These are the little stars. These are little radios. And I can see the signal strength on each of these radios, and they're listed here -55, 56, etc., with a noise floor of -100. So in a point-to-multipoint environment, you'll have one side on the left here. He is my access point, and then we have all of these guys as stations. You can see at the far right-hand side, near the bottom of the screen here, we have a station that's reporting a signal of -82. Well, this is a very weak signal. The problem with an outdoor client radio receiving a poor signal like this is that there'll be a lot of retransmissions. There'll be several retransmissions when the client is actually polled to say, hey, are you ready to move data? So TDMA is really a polling protocol where the stations are polled in turn. Are you ready to send data? Go ahead and send it. And then the next station in turn, are you ready to send data? The reason TDMA doesn't work like indoor access points is because they don't really sense each other. These clients would never sense each other. And we had talked about carrier sense before. So outdoor clients don't really sense each other. That's why they use TDMA. Well, TDMA sounds boring, which it kind of is. So TDMA is actually been converted and modified into AirMax. Okay, so TDMA is now AirMax on outdoor radios. So we are using AirMax, which can take the TDMA protocol and modify it to improve our network. So how do we modify our network in this case to facilitate a better signal at this guy here, or to facilitate a better network? Well, what we can do is we can modify that particular timing polling interval that particular customer gets. Okay, so what we're doing is we're modifying the polling interval. We're allowing more polling intervals for well-connected clients, these guys on the left here, and we're giving less polling interval time to the guy on the far right. That's what TDMA AirMax based priority is actually doing. So we would set these fellows here on the left to high, right? We'd give them the high, and we would set this fellow way over here on the right to low. Now, if there was customers, in between there, they could be medium or they could be base. But in this case, setting the low station priority means that this guy with the -82 signal will not be able to monopolize the polling interval and the airtime. That's what this actually means. All right, so let's go back. So for this particular station, if this was the station that was receiving a very poor signal, we would set this station to low, just like that. So that's kind of what this actually means. All right, that's kind of what this is representing. So people that weren't really sure about AirMax station priority, that's what this does. Now this does not show up as an option if the radio is set to be an access point. It doesn't show up as an option. Okay. Underneath that, we can see that there's a maximum TX data rate, and by default it's set to auto, and Ubiquiti does recommend setting this to auto. But underneath that, we can see QPSK, 16 QAM. We can see these different modulation rates. Basically, you could force a device to only modulate at a certain rate if you wanted to. I don't recommend this. I would rather let the radio run on auto. Now, on the far right-hand side, we see calculate Eirp limit, and there may be some people I've met in the past at various WISPs who like to turn this off so they can actually get a little more transmit power out of their radio to make a better connection. That's kind of what this would do. I don't really recommend doing that. For this very low-powered radio, you will never exceed the FCC allotment for power or output. So again, EIRP is effective isotropic radiated output. This is the total amount of power this radio can put out. This particular radio, very small radio, would never exceed any regulatory limits, so it wouldn't harm the environment at all by turning this off. Underneath that, we have sensitivity threshold and automatic power control. Now, if I was to go up and change the type to access point on, let's turn that on, okay, and we'll just go back down here to look at that again. Now we can actually see that sensitivity threshold. If I turn this on, I can actually modulate on this side of the link. This is the access point side. What minimum setting sensitivity threshold that I would require a client to get to make a connection to me. In this case, if I set this to -73, then the client has to be able to receive a signal of at least -73 to make a connection to this particular access point. That's what this does. Now, automatic power control underneath that, if I select that, you can see it represents target signal and shows a -60 by default. And if I turn this on the client side, and on the client side it's just on and off, the radios will continually to modulate their own power to try to achieve this target signal of -60, which is kind of clever. And it actually does work. I have set this up in a lab environment, and it actually does work. So we're going to pause the video right here. So just pay no attention to me right now. We're going to be pausing. Okay, so hold on. All right, so this is the unpaused. Okay, so 3, 2, 1, go. All right, so underneath target signal, we see this RESE. This is a receive signal sensitivity. If you hover over the exclamation or the question, it'll actually tell you receive signal enhancement improves receiver performance for the entire network. We recommend leaving this enabled unless you see varying receive signals due to obstruction or alignment changes. Again, this is the internal operation of the radio trying to automatically adjust various levels of power and sensitivity to try to enhance or get the best signal possible. That's what this actually does. Does it work? Yes, it does. Absolutely. However, like I said, I didn't want to make a huge long video. I did want to show some basic things in the AirOS that people are confused by. AirMax protocol is definitely very, very cool. You should do more research on that if you're setting up outdoor radios and how it actually does its thing as opposed to TDMA. So again, so the quick and dirty video, next one we're going to do on SSH keys and how to actually set that up for both the indoor radios and the outdoor radios. That's it. Thanks for watching.